Welcome to Lesson 12. This lesson will be broken into 3 pieces. I'm Miss Adams from Flamingo Math. Today we're talking about equivalent representations for trig functions. We're going to jump into the idea of identities. We know our fundamental identities from several lessons ago, and we're introducing Pythagorean identities today. Sine squared plus cosine squared equals 1. This is my main go-to identity right here. If I know that one, I can derive the other two using graphs. So let's jump into that proof right here. If we know that basic identity and we have a right triangle, so I'm just going to sketch one really neatly in here. So I got a hypotenuse or a terminal angle here. We're dropping that identity, that perpendicular back down to the x-axis, and we know that the sine of theta is the y-axis. We know that the cosine of theta is the x-axis. We have this terminal point here, xy, and our angle we're calling theta. So if it's on a unit circle, that value is 1 and this value is 1. And like I said, if you start with the basic fact that we know x squared plus y squared equals the hypotenuse squared, and you know that the cosine squared is the x value and the sine squared is the y value, we can derive that from the circle equation. This is our standard equation for a circle centered at the origin with radius 1, and that gives us that basic identity back here. Okay, so we have this basic identity. And we can derive the other formulas by taking that basic identity, and I want to divide cosine squared theta plus sine squared theta equals 1. So the second identity can come when we divide each term in that equation by cosine squared. So dividing every term by cosine squared, we'll end up with cosine squared divided by cosine squared, that's 1. Sine squared over cosine squared is tangent squared, and 1 divided by cosine squared is secant squared. So we've derived that second formula right here. And then taking that formula again, and this time we're going to divide each term in the cosine squared plus sine squared equals 1 identity. We'll divide it this time by sine squared. So each term is being divided by sine squared, and you can always derive the 3 formulas. Cotangent squared plus 1 is equal to cosecant squared. So that's how we can derive those 3 equations. You memorize the first one, so we want to memorize this one and use it by dividing each term by cosine squared, and by dividing each term by sine squared, you'll derive those other 2 formulas. So it cuts down on memorizing. Let's move on to example 2. We want to use a quotient identity to simplify and rewrite each of the terms. So using cosine, we can turn tangent into sine divided by cosine. And we want to see, does that really equal the sine of beta? And checking that cosine on the numerator here divided by cosine on the denominator definitely proves that sine of beta is equal to itself. So cosine times tangent definitely equals sine. Following that same thinking here, sine times secant sine is 1 over cosine, is that equivalent to tangent? And yes, we can see that sine divided by cosine is equal to tangent. So the left side of that identity is equal to the right side of that identity. These are like proofs back in geometry, but we're proving trig statements. For example 3, another idea is to decompose a fraction. Now, when I say decompose, I think of this as this is one fraction and this is another fraction, and we're subtracting those fractions. So decomposing looks like this: sine divided by cosecant minus cosecant divided by cosecant. I want to know if it's equal to this term, so let's think about that. Sine, this is a 1, so sine, I could move this cosecant up to the numerator, and I would have sine times sine. And this is minus 1, so minus 1. And sine times sine is sine squared minus 1, and that's exactly what we were looking for. Is the left-hand expression equal to the right-hand expression? And they are. On part B, I want to rewrite, let's see, secant squared could be 1 over cosine squared. And tangent on the bottom is like a cotangent. So cotangent is a cosine divided by a sine. I want to know, is that statement equivalent to secant times cosecant? These are like little puzzles to me. So if we cancel a cosine in the numerator, that would get rid of one cosine in the denominator. And 1 over cosine times 1 over sine can be rewritten to be secant times cosecant. So yes, they are equivalent, secant times cosecant. They're the same statement. In example 4, verify the identities by changing everything to sine and cosine. So sine squared, we want to look at these two terms. We want to turn those into either a sine or a cosine statement. Sine squared times secant times cosecant. We want to know if it's equal to tangent. Sine squared, I could cancel a sine squared with this sign and end up with a sine times a 1 times a 1 over a cosine times a 1 times a 1. You see where I'm getting the 1? And that is definitely equal to tangent. So tangent is equal to tangent. That's a true statement. On part B, I have sine times tangent. So rewriting tangent as a sine over cosine and adding cosine, we want to see if it's equal to secant. Multiplying this together, we get sine squared over cosine plus a cosine over a 1. So my idea is going to be multiply cosine over cosine times this fraction. That's going to give us a sine squared over a cosine plus a cosine squared over a cosine. And you see we have two fractions with a common denominator. And if you add the numerator, sine squared plus cosine squared, these two terms, this plus this added together is just a 1. So 1 over cosine, what is 1 over cosine? That's secant. And what were we wanting to get back here at the beginning? We wanted a secant, and we got what we wanted. Okay, so these are fun. Just don't get discouraged. We got 2 more to go. This one, example 5, we want to verify using Pythagorean identities. The first one I'm going to take, let's see, I want to multiply both sides by cosine. So cosine of x over cosine of x times that left fraction, cosine of x over 1 minus sine, and then minus sine divided by cosine. So we want to multiply this fraction by the other denominator, which is 1 minus sine divided by 1 minus sine. So this is how we're getting that common denominator. Get a common denominator. And I want to know, is that really equal to the secant of x? This multiplied together is cosine squared, and I'm going to keep that common denominator because we have cosine of x times 1 minus sine of x. You can tell this is that denominator here, and it's the same denominator here. And multiplying by the numerator, so we've got minus a sine times 1, and then minus a negative. So a negative sine times a negative sine is a positive sine squared. Is that equal to secant? I don't know yet, but I see cosine squared plus sine squared, that's a 1, and a 1 minus a sine x divided by a cosine times a 1 minus a sine x. Is that equal to secant? If you think about the numerator, this divided by itself just leaves a 1 in the numerator. 1 over cosine is definitely secant, so we've proven our identity. The left side is simplified down to secant. So we used the Pythagorean identity in this step, where cosine squared plus sine squared is equal to 1, and that was our directions. Prove this by using the Pythagorean identity. And then our last example, verify and identify the identity using algebraic techniques to simplify. I want to multiply the left side by 1 minus sine on the top and the bottom. So 1 minus sine times the left is cosine over 1 plus sine. And I don't want to touch the right side. I want to prove the left side is equivalent to the right side. That's my task. So distributing 1 to both of those, we have, let's see, let's just leave that alone. Let's have cosine theta times the 1 minus sine theta, and then we'll distribute 1 to both those terms and 1 to both, and sine theta to both of those terms, and we'll end up with 1 minus sine squared theta. Is that equivalent to the right side of the expression? Well, here's the idea. Okay, so my idea was sine squared plus cosine squared is 1. And if we simplify, 1 minus sine squared, see it? 1 minus sine squared is equal to cosine squared. So we can replace the denominator 1 minus sine on the top. We can replace this denominator with cosine squared. Cosine squared. And then what's beautiful about that is a cosine in the numerator will cancel a cosine in the denominator, and we'll have 1 minus sine in the numerator and only cosine theta in the denominator. And look what we wanted. We definitely have the left side of the original expression can be simplified to give us the right side of the original expression. And we have proven our identities in multiple different ways. I'll see you for the second day of the lesson.